All right, right now, this problem one is a review. So I want you guys right now, you should have two different colored twistables. We're going to be talking about the domain, how far it goes left and right, and the range, how far it goes up and down. So right now, in your journals, you already have this drawn out. Right now, you should write the word domain right here. This is the domain of the graph. And this right here is considered to be the range. Okay? The domain deals how far to the left and how far to the right does this particular graph go. We're looking for what's the largest number and what's the smallest number from left to right. So if we were to look from left to right, what is the smallest number that it gets to on the x-axis? Negative what? Negative 5 is right. And how far does it get on the x-axis to the right? It would be the maximum. Where's it pass through? Right there. Right there. 7. It goes all the way over to a negative 5 and all the way over to a 7. Over here, we have a closed-in dot. Over here, it's open. So if I were to ask you to write your domain in set builder notation, you say the set of all x values such that x is less than or equal to a 7, but greater than a negative 5. And that would be your answer in set builder notation. This is the max, that's the biggest. This is the smallest, that's called the minimum. Okay, you always list it from what? Least to greatest. Okay, right now we're going to be talking about the range. Okay, the range is dealing with not the set of all x values, but the set of all y values. So here we're going to put the minimum. Over here we're going to put the maximum. Okay, so right here, how high up do I get? What's the maximum height that I get in the graph? 5. He's looking at x. He's looking at x. That's how we got to 7. Over here, when you're looking at the range, you don't look at the x-axis. What do we look at? We look at the y-axis. Right here. So right here. So all the way up here. Actually, hey, I'm glad that you said that because honestly, lots of people get that confused. So it's okay. 5. How low do I get on the y-axis right here? Negative 3. So put a negative 3. That's the minimum value. Okay? Up here, there's a closed-in circle, right? It's closed in, which means it's at that point. It's equal to that point. So we're going to put it's less than or equal to the number 5. All of my y values are less than or equal to the number 5. But that's an open circle. What does an open circle right there mean? Does it include the number or not include it? Does not include it. So it's not equal to it, it's just greater than a negative 3. So look here, why don't I have equal to signs right there? Because over here, on the far left, it's open. And as far down that it goes, it's also open. So there's not going to be an equal to. Okay? So these are your two answers for the domain and the range. Good. So determine the what? Domain and range. Did we do that? Yes. And represent the domain using what? Inequalities. That's what these are. These are inequalities right here. Okay? Identify the domain as continuous or discrete. Ooh. So ask yourself, from here to here, would my pen ever leave the line? No. So from here to here, that's considered to be continuous. Could you guys please write the word? This is continuous. Okay? Continuous because technically all of these points between this dot and this dot are being plotted. Now what is discrete? Discrete, just think of ordered pairs or dots. I don't know why it's not writing there. So let me explain to you what it would look like if this were discrete. If you saw points just being plotted like this, then that would be discrete. And then you would have to list each of the ordered pairs as your domain or your range. You wouldn't use inequality symbols. You would just use ordered pairs as your domain and range. So you list a set of numbers for your domain and range. Now this is something that's new that we're going to be talking about. Section 2, it says calculate the slope and rate and change. They mean the same thing, slope and rate of change. So here's what I want you to do in your journal. I want you guys to write the word slope. Write the word slope. Okay? We're going to talk about the 4 different types of lines you can see. You can see a horizontal line. You can see a vertical line. You can see a line going up from left to right. You can see a line going down from left to right. So when we talk about slope, we're going to be talking about each of these and what they mean. Could you guys walk across? And that's a horrible stick figure. But could you walk across that? Yeah. It'd be pretty easy to walk on it, right? Because it's not going up and it's not going down. That is what's known as a zero slope. So write 0. That's a zero slope. Okay? If somebody says, hey, what's the slope of that line? You say 0. Hey, what's the slope of that line? 0. 0, you're right. Good job. Let's say it with enthusiasm. Okay. Now, could you walk up that line?
Yes.
All right? From left to right, what's happening from left to right? Is it going up or down? Going up. That's called a positive slope. Yeah. So he's going up. It's positive. You're going up from left to right. Could you walk? Yeah, that's going downhill. Hopefully that's not your stocks and bonds. All right? That's called a negative slope. All right? Now, I got to say this. You are not Spider-Man. So listen.
I am too.
No, you're not. You're not Spider-Man. Okay? Uh-oh. This is the only situation where you would be in a very, very, very bad shape in real life. Okay? This slope, everybody, is called undefined. Okay, that's called an undefined slope. You would fall. I'm saying, Jordan, you would fall to your death. Well, it depends. If there was a net, it caught you, it'd be okay. Right? If there was no net and you were up hundreds of feet, you would die. Right? So, zero slope, undefined, positive, negative. This is your introduction to slope. It's dealing with the concept called rate of change. Okay? Which is also dealing with something we refer to as steepness. Okay, the steepness of a line. So all this stuff we're going to be talking about today. We're going to be talking about slope. Alright, so everybody, what I'd like us to do right now, it says we need to do what? Calculate the rate of change or slope for the following linear functions. So this right here is a table. Okay? So we're going to calculate the slope. Now there's a slope formula. Okay? Slope is often referred to the letter N. You'll see it in different forms. Okay? So put N equals. All right? What I'd like you to do is write this formula down. Y2 minus Y1 over X2 minus X1. This refers to, sometimes you'll see it like this, delta Y over delta X. Right? What the heck does that symbol mean? That means delta, which means changing. You'll see that in science class a lot, dealing with changing temperature and stuff like that. Okay? So right now, slope is talking about what's called the change in the Y values over, divided by, the change in the X values. Most often referred to as the rise over the run. Okay? The rise and the run. The rise deals with the up and the down. The run deals with the left and the right. So write those down. This is what all of the slope or the steepness of lines, how you can find them. So we're going to talk about which ordered pairs you can choose in this table to calculate this slope. So we're going to actually choose 2 sets of ordered pairs. Okay? I'm going to do 2 different ones. Alright, what I'm going to going to do right now is I'm going to highlight a set of ordered pairs right here in blue, and I'm also going to highlight a set of ordered pairs in green. Okay? So right here, this says -5 and a 7, so that ordered pair you write. Let me change to blue. -5 and 7. And then we have a 1 and a -5. Over here in green, I have 7 and -17. And I have 9 and -21. Now what I'm going to do is I'm going to label these. I'm going to call this my x1. I'm going to call this my x2, which means first x coordinate, second x coordinate. I'm going to label this my y1. I'm going to label this my y2. Over here, I'm going to call this x1 and x2 and y1 and y2. And when I label these, I want you guys to understand, it doesn't matter which one you label as x1, but you got to keep it the pattern. If that's x1, then this has to be y1. If that's x2, that has to be y2. So you're saying first x coordinate, first y coordinate. So go ahead and label everything out. Okay. So we're going to find our slope. So you guys are going to notice I'm going to do something whenever I find slope using the slope formula. I always use parentheses. And I always label those. And the reason why I label them, what I found over time, the more I keep things organized, the more likely I am to do all of the processes correctly. The faster I do it and the least organized I am, the more likely I am to make a mistake. So I'm going to label this. This is y2, this is y1, this is x2, this is x1. y2, y1, x2, x1. So I'm using this formula right up here. I'll put a little box around it. Let's see here. This is our slope formula right there. That'll actually be on your star formula chart. That'll be on the formula. You don't have to memorize it. You just have to know how to use it. So if you forget the formula, it'll still be there when you're taking the test. Okay, once you have everything organized, all right, it says y2. So I look for my y2, which is a -5, and I'm going to put it in right there. First thing I'm going to do. Plug in a -5 right there for y2. Now I'm going to scan over to my y1. My y1 value is a 7. I'm going to plug in a 7. Now what does that mean? That means -5 minus 7 more. If I do -5 minus 7, that gets me to a -12. -5 minus 7 more gets me to a -12. Now I'm going to look at x2. My x2 is the number 1. My x1 is the number -5. Hopefully you'll understand why I use parentheses right now. Because if I have a 1 and I'm taking away a negative, if I have negatives right there, what's going to happen to those? Negative times negative is a positive. So 1, it becomes 1 plus 5, which makes that a 6. -12 divided by 6 becomes a -2. So my slope, my m value, my slope is a -2. That's what my slope is. Using what? Using these two ordered pairs. Now I use these two ordered pairs, but I also over here use these two ordered pairs. What I want you to show, it doesn't matter which two sets you use. You could use any sets of them and you should be able to get the same answer if it is a linear function, because it has a constant rate of change. The rate stays the same. So what's my y2 value? Y2 value in this one? -21. What's my y1 value? -17. Now what happens with these negatives right here? Right, so it becomes -21 plus 17. And -21 plus 17 becomes a -4. x2 value is a 9. x1 value is a 7. That's just saying 9 minus 7, which is a 2. What's -4 divided by 2? Still a -2. So what did I I get both times for my slope? -2. Now I could keep going and finding any sets and using any two sets of these ordered pairs, and you should still get a -2. I just did two of them, knowing that you have a choice. Did I have to choose a -5, 7, and a 1, -5? No, I could have chosen any 2 points. Any 2 points would get me the same slope. Now, your guys like, you know what? I can't do all this in my head. Let me show you how you can do it in the calculator, all right? Go to the calculator. Let me get out of my tree cal. All right. So everybody hit alpha y equals enter. Alpha y equals enter. Okay? Alpha y equals enter. I'm going to open up an ordered pair. I'm going to look at my ordered pairs. I said what? -5 minus a 7, right? So over here, I'm going to go -5, close parentheses, minus, open parentheses, a 7. Okay? And what did I put in the denominator? A 1 minus a -5. So in parentheses, I did 1 minus a -5. And I press enter. What do you get? -2. So you can use the calculator to do that. I'll do the other one. Here we go. Alpha y equals enter. Okay, I'm going to open up the parentheses. Carly, what was my first number I plugged in? -21, and then I closed it and put minus, open parentheses, and what? -17. Good. Went down here, and then what was the first one number? 9. I think it was 9 minus 7? Yeah. Okay, so 9 minus 7. Just like that. Press enter, what do you still get? -2. Okay? This right here will make it very, very easy if you just want to find slope. Now, here is what I could do as far as if you want to make sure you get it right. Here's what you could do. You might want to write the keystrokes down. Everybody hit stat. Enter. Stat. Enter. If you didn't catch that, we'll go back to our regular screen here. Ready? Going to hit the stat button right here. There's the stat button. Press enter. What I need you guys to understand, in the calculator, L1 represents your x values. L2 represents your y values. This is your x. This is your y. Grace, could you give me one set of ordered pairs for our problem? Of all of these, hold on. Where is it? Not that one. Oh, there we go. Give me any 2 ordered pairs of this list. All right, any 2. You ready? Go ahead. -5, and then this one was over here was a 7. Okay. Enter. Go down. Which one? Give me another ordered pair on that list. 1 and a -5. So you have these. This is your x value. This is your y value. This is your x value. This is your y value. Go ahead and type those in. Go ahead. Okay, this is gonna be a little confusing. All right, because it's the first time you've done it. Just watch. You're going to hit the stat button again after you've done it. But this time, I want you to move the right arrow to where it says calculate. Now, by the way, this is part of a linear function, right? So can you guys go where it says LIN, which is short for line? Do you see where it says AX plus B? The A is going to be your slope. In the graphing calculator, A represents slope. Okay, here we go. We're going to go down to number 4. All right, I'm going to take a screenshot of this, okay? So right now, what does X represent? We're going to go ahead and, oh, you want to go back to, okay, here we go. I'll go back, here we go. But it's stat, enter. You have those ordered pairs in? Right. Okay, stat again. Go to the right where it says calc, or calculate. You go down to number 4. All right, I'm going to take a screenshot of this so you guys can see what's going on. You see where it says X list is L1, Y list is L2. That means X represents your domain, the L2 represents your range. You see where it says AX plus B? You guys remember last year when you guys were introduced to this, MX plus B? All right, what does M represent? M represents your slope. But this time, in the graphing calculator, these mean the same thing in the graphing calculator. So watch this. This is going to be so awesome. We already know what our slope is. What is our slope? -2, right? -2. So watch. What you're going to do is you're going to press enter, 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 enter. What are we going to do? We're going to, it's flashing, calculate. Press enter. What does it say our slope is equal to? Aha! That's our slope. I wonder what the b value here represents. That's the y-intercept. We'll learn about that later. Okay? There's the slope, there's the y-intercept. So our equation for this line would be negative 2x minus 3. That would be the equation of the line. You didn't need to know it for this problem. What were we just trying to find on this problem? We were just looking for one thing. What? Slope. So the calculator can find the slope for you. By the way, you think this is the only time we're going to do this? No, we'll do it multiple times until you guys get it right. Okay? So here we go. We just found the rate of change. What was the rate of change of this table? What was our slope value equal to? Negative 2. That was the answer to 2a. Now, what we're going to do, some of you should already know the answer to b. That's a horizontal line. It's neither going up nor down. What's the slope? No, it's neither going up. Yes. Yes. That's okay. It's not like it's being recorded and put on YouTube for it. All right, here we go. Would you like to have a chance to redeem yourself? Yes, good job. Look at that. Now you were recorded forever. Saying undefined. All right. So we have a 0 slope and we have an undefined slope. Now I'm going to give you guys a point. See, I'm going to do it in red so you can see a little bit easier. Here we go. Put a point here. Put a point right there. Put a point right there. Put a point right there. Now I'm going to show you guys a little pattern right here. So see if you guys can follow this pattern in red. Here we go. Down 1, over 2. Down 1, over 2. Down 1, oops. Down 1, up. Come on. You can do it. There we go. What did I keep saying? I kept saying do what? Down 1 over 2. So I'm going to put down 1, which means it's going negative, over to the right 2, which is positive. What is this slope? This slope is called a negative 1. Yes. So, yes, technically this is a negative slope, but more specifically, when it says find the slope of each graph, this is going down 1 over 2, down 1 over 2. That's a negative 1, it's going over 2. That's called a constant rate of change. It's always going down 1 over 2. That's what makes a linear function a linear function. A linear function will always have what? It'll always have a constant rate of change. If it doesn't have a constant rate of change, it's not a linear function. Here you guys, you have a chance. Right now, if you're watching the video, pause it and try to come up with the slope on your own of this one. Now, by the way, it is a positive slope. I will give you that. But now I'm going to pause my video, and my students are going to find the actual slope of this line that goes up from left to right. All right, so let's check this out. From right here, I can go up 2 and over 3. If I go up 2 units, that's positive. If I go over 3 units, that's also positive. So I can go up 2 units, which is positive, and I can go to the right 3 units. So this is actually considered to be a positive slope of 2/3. Now some students will do this. From this point, they will go down 2 units and over 3 units. So watch very carefully. If I go down 2 units, that means it's going negative 2. If I go to the left 3 units, that's negative 3. Well, what's negative 2 divided by negative 3? What does that have? What happens to those negatives? They cancel to a, so you still get the same answer. Whether you go up 2 over 3 or down 2 into the left 3. Down is always negative, to the left is always negative, up is always positive, and to the right is always positive. So that's why your slope is a positive 2/3. Boom. That. You don't have to edit that. All right, hold on. Oh, that's wrong one. Sorry, wrong one. Hold on. Nope, not that one. There we go. Okay. Everybody, here's what I need you guys to do. This is the last thing we're going to do today. Right now. I need you guys to highlight slope-intercept form and write slope-intercept form in your journal and write down this example for slope-intercept form in your journal. Then, I want you write the words point slope form. Write that in your journal, and here's an example of an equation in point slope form. And last but not least, write standard form in your journal, which this is the example of standard form, and here's an equation in standard form in your journal. Write that down. All right, unfortunately we're out of time today, so we're going to have to pick up this tomorrow. We're going to talk about slope-intercept form, point slope form, and standard form, and how to find the slope in all three forms. Two of these are very easy. One is slightly more difficult.